Good day, viewers. I welcome you to our continuation series of science and mathematics learning. Which subject are we looking at today? And what is the topic for today? We are going to be looking at the subject chemistry. And the topic before it is on atom, molecule, and atomicity. In the last class, we look at element and symbol, where we mentioned something that elemental unit is atom. So atom is related to elements. So when you are talking about atom, you're also talking about what? Element. So let's take it off from there. But before we dive into the topic very well, I would like us to look at some of our learning objectives like we normally do on this channel. What are the things we want to achieve, want to know in today's topic? So let's go over our learning objective. Now, the first one, we are going to define what is an atom. We will look at structure and constituent of an atom. We now move on to the characteristics of subparticles of atom, the things that are inside atom. We now move on to definitions of molecules. What is a molecule? Examples of molecule. Again, we go to atomicity. We are going to define atomicity. Likewise, we look at what? Explain the atomicity. Now, not wasting our time, what do we call atom? Atom related to elements. Elements are very, very important. We have so many elements, like you said. But inside this atom, inside this element, which are related, an element can simply be defined as the smallest particle of an element, which can take part in a chemical reaction. So that means an element and atom are more or less the same. They are related. So we define atom as the smallest particle of an element, which can take part in a chemical reaction. Let's put it down. So let's put it down. What is an atom? Let's put it down. An atom, okay, atom. See, an atom, okay, is the smallest particles of an element, okay, which can take part in a chemical reaction. So which can take part in the chemical reaction. So the elemental unit is called atom. So that's how to define atom. You see, I mentioned element here. So element and atom are more or less, they are related. Okay. Having said that, what is it? Let's look at the structure of atom and the constituent. If you look at this atom will also have subparticles. There are some particles that are inside the atom. Okay, that's why some people say an atom is the smallest divisible particle of an element. So that means there are some other subparticles inside this atom. So let us look at the atom a tiny bit. So look at the structure of an atom. At the center here, we have what is called nucleus. What do I call it? Nucleus. Inside this nucleus, at the center of the atom, we have two particles called what? The neurons. Neurons. And the second one is called what? Protons. Protons and neurons are inside the nucleus. And orbiting around the nucleus like this in electrical way. Okay, this thing is called electrons. Electrons are located outside the nucleus. So that's what we are saying. So we have protons and neutrons inside the nucleus, and they're moving around in an orbit. We call electron. In fact, this thing is sometimes being called shell, where we normally locate the electrons moving around the nucleus. Okay, now from this diagram, we can see that our atoms comprise of three main subparticles: electrons, protons, and neutrons. Okay, having said that, let us now tabulate to look at the characteristics of each of these subparticles. Characteristics of protons, electrons, and neutrons. So let's put it down. We shall call subparticles. Let's start like this. Subparticles. We have subparticles. We have what's called location, where we find them. What's called here? The charge, relative charge. What is their charge? And then what? About their mass, relative mass. Okay. Let's take the first one, which I call electrons. Electrons is located, you can see, outside the nucleus. This is the nucleus. Electrons is outside the nucleus. So you can put it there, outside the nucleus. Okay? The charge of the electron is negative. Okay? The mass is 0.05. Very small. Followed by what? Protons. See the proton inside the nucleus. Inside the nucleus. Okay? And the charge of the protons is positive. That one is plus, positive. That is why they normally say an atom is electrically neutral. What do you mean by that? If a particular element, let's say sodium, atomic number of sodium is 11. So the number of protons there is 11. Number of electrons is also what? 11. So 11 cancel 11. So sodium atom is electrically neutral because they have equal number of protons, equal number of electrons. The same goes to other elements. Most of the elements, all elements are electrically neutral. Equal number of protons, equal number of electrons. Now, having said that, what about the third one called neutrons? Neutrons, you can see from the diagram, neutrons is also found inside the nucleus, just like protons, inside the nucleus. Okay, what is the charge? This one is nil or 0. It does not have charge. Since your protons number is equal to your number of electrons, so the neurons does not have charge. So when you look at the mass of the proton is found to have a mass of 1. Neurons have mass of 1. Only the mass of the electron is very, very small. Mass of the electron, how weighty it is. So that is that. We have looked at the characteristics of some of these subparticles. Let us now look at the next one, which is called what? The molecule. What is a molecule? What is a molecule? Now, when you talk of molecule, this molecule also related to element and compound. A molecule is the smallest particle of a substance that normally exists alone and still retain the chemical properties of that substance, be it element or compound. A molecule is the smallest particle of a substance that normally exists alone and still retain the chemical properties of that substance. That substance can be element or compound. So what you are trying to say is that a molecule can be in form of what? Element, or in form of what? Compound. Why do we say in form of element? Some atoms are capable of existing independently, can capable of existing alone. So that's why we say one of the ways of writing the formula of a molecule, some molecule can exist independently. They are made up of one single atom. Some molecules are being formed when atoms of the same element joins together. They form a molecule. Atoms of the same element comes together to form a molecule. That's why I normally say H2. Hydrogen gas is H2. Oxygen gas is O2. Chlorine gas Cl2. Atoms of the same element come together to form a molecule. And at times, the third method, atoms of different elements can come together to form a molecule. Example, if you look at H2O, water. Water is what? H2O. Hydrogen is there, oxygen is there. Okay, having said that, let us put it down. What is a molecule? A molecule, put it down. This is the smallest particle of a substance. Smallest particle of a substance that normally exists alone and still retains the chemical properties of that substance, be it elements or compound. So our molecule can be in form of element or compound. So let's explain more. Let us look at examples of a molecule. What we are saying. Let us look at example of a molecule. I mentioned earlier on that a molecule can exist singly, can exist as a single element. Example, some metals. First one, you write something like this: helium, neon, krypton, xenon. All these ones, they are all what? They are all molecule. They exist singly on their own. We call them, most we call them monoatomic, one atom. So they are also what? Molecule. Some molecule contain atoms of the same element. Example, if you write H2, O2, Cl2, so this one contains two atoms of hydrogen. Two atoms of hydrogen. Hydrogen comes together to form H2. This one contains two atoms of oxygen. So two oxygen comes together to form O2. This one's two Cl2. Two atoms of chlorine comes together to form Cl2. Okay, so these ones also are molecule. The third category, in form of compound. Your molecule can be in form of what? Compound. Example, H2O. Okay, HCl, hydrogen chloride. If you look at H2O, H2O is a molecule. Why? It consists of two atoms of hydrogen, one atom of oxygen. So this one made up of what? Like this one, three atoms. This one is also a molecule, hydrogen chloride. So made up of hydrogen and chlorine comes together to form hydrogen chloride molecule. So this one is a molecule. One of them are molecule. So a molecule can exist singly as an element. When two elements combine, more than one element to form in form of what? Compound. That's what we are saying. Okay. Now let us now look at the last 6 agenda there, 6 learning objective. What we call atomicity. What is atomicity? Atomicity and atom, they are the same thing, related. Atomicity, this one has to do with the number of atoms present in one molecule of an element. So number of atoms present in one molecule of an element is called atomicity. Okay, let's put it down and explain more. So atomicity, let's put it down. Atomicity. I said this is the number of atoms present in one molecule of an element or compound. One molecule of an element or compound. Why do we say element? Find out that some element can be in form of what? Molecule, and some compound in form of what? Molecule as well. So let us write down substances. Let's say in form of the example, explain more. Substance, formula. Their formula, and then what? Atomicity. Atomicity means number of the atoms in each one of them. Let's take a look at one. Let's say helium, He, helium. Let's put helium, He. It is 1. Atomicity is 1. Let's look at neon, Ne. Atomicity is also what? 1. Let's move on to hydrogen, hydrogen gas, or hydrogen gas. You write H2 like this. So atomicity here is 2. What about oxygen? Oxygen, O2. Atomicity is also 2. Number of the atoms correspond to the atomicity. Let's look at ozone. Ozone, another beautiful O3. Atomicity is 3. Okay. What about another one called? Let's look at H2O. Water. Let's put it down. Water. Water is a molecule. H2O. Atomicity here is going to be 3. How? H is 2. O is 1. 2 plus 1 give us what? 3. Atomicity here is 3. So we can be able to see the number of the atoms we have in each of the formula correspond to the atomicity. This one is 1, this one is 1, this one is 2, oxygen is 2, ozone is 3, and then what? Water is also what? 3. 2 plus 1 is 3. So we are be able to see that most of these elements, their atoms and their atomicity likewise were molecule. So we are be able to achieve all our learning objects. We have defined what is atom, we have drawn the structure and the constituent of atom, we have looked at characteristics of these subparticles of atom. Likewise, we have looked at what? Definition of molecule, example of molecule. We've talked about atomicity, and we have explained what is atomicity, which is the number of atoms present in one molecule of an element. Okay, so this is where we are going to stop today. In the next class, we are going to take it off further from there. Probably we are going to look at compound, another very, very interesting topic, compound. We've talked about element, we've talked about atom now. Later we'll move on to compound. You see how compound is being formed, what are the things that compound contain. So till we meet again, kindly subscribe to my YouTube channel. Click subscribe so that you can be able to see all different subjects we normally do on this channel. Name it chemistry, name it physics, name it biology and mathematics beside the chemistry. So all these areas we normally touch on this channel and different topics. You can be able to see all the topics we have done and the subject. Till we meet again, I still say we should remain chemically and scientifically intelligent. Bye bye.